Good morning, guys. Today in climatology, we'll be looking at air movement and natural ventilation. So first, we'll try and understand what exactly is ventilation and what are the how ventilation is majorly subclassified. So in this, we will be majorly looking at natural ventilation, and we'll also be looking at the techniques that have been used in the past to deal with ventilation and how those techniques have been adapted in the present. So starting up with it, so ventilation, what exactly is ventilation? So ventilation is the process by which the fresh air is introduced and used air is removed from an occupied space. It's basically a process that goes about by the where there's a transfer of air towards from one space to other, and where they have actually to try and bring in fresh air and trying and remove the old used air that is being circulating inside a space. So what happens is that it also provides cooling by air movement. By doing this, when this process is happening, as this goes on about, there is a cooling in the system, and thereby it's called that cooling by air movement. So usually an indoor air speed of 1.5 to 2 meters per second can cause comfort in a warm and humid regions where the outdoor maximum temperature does not exceed 28 to 30 degrees Celsius, 32 degrees Celsius. So it's basically we have tried to give us enough understanding about what is the speed of air movement that is supposed to be there in a place when there is, in warm and humid areas where they have an outside temperature of 30 to 28 to 32 degrees Celsius. So this ventilation, what the main and the primary aim of ventilation is to preserve the quality of air. Sometimes ventilation may also be used to lower the temperature inside an occupied space. So this ventilation, when this movement of air is talking about improving the quality of air, they may also go about to talk about how this, we were talking about the cooling the air movement goes on about to help lower the temperature inside the occupied area. So as we had discussed earlier, we were trying to get in about like what are the types of ventilation. So there is your natural ventilation and your mechanical ventilation. So your natural ventilation is basically the process of supplying and removing air by means of a purpose-provided aperture. So basically these purpose-provided apertures are nothing but your openable windows, ventilators and shafts. Okay, and then the natural forces of wind and temperature difference pressures. So these are the major elements that go about to create a natural ventilation. You could see how these elements play a major role in your natural ventilation. In your natural ventilation itself, these are again subclassified into two types. That is your controlled natural ventilation and your infiltration. Your controlled natural ventilation is nothing but your intentional displacement of air to specified openings such as the windows, listings, windows, ventilators, doors, and by the means of natural forces. That is, these natural forces are nothing but which are caused by the difference in pressure. So this difference in pressure helps us to the movement of air, or this either be a difference in temperature. So how this goes about is that because of these temperature differences, the movement of air goes about through these openings. So these are usually controlled to some extent by the occupants. So basically, these are elements which have, closings where these can thereby be controlled by the occupant. Whereas when we are talking about the infiltration, it is actually the uncontrolled flow of air through unintentional openings driven by the wind. And the temperature difference pressures, or these all, they are when all of these pressures that go across in a building envelope. When we are trying to look at building envelopes that have very closed and packed closings, like you could see in high-rise buildings and all of those stuff, these are more of infiltration becomes a major component in your movement of air. So this infiltration cannot be so controlled, and it's very less desirable because the occupants don't have much control over it. But what happens is that it becomes a main source of ventilation when it is an envelope dominated building. So how about like how these two are classified is what we are talking about. Now, when we are looking at your mechanical ventilation, the mechanical ventilation or your forced ventilation is basically the process of supplying and removing air by the means of mechanical devices that are such as fans. It may be arranged to provide either supply, extract, or balance ventilation for an occupied space. So if you're looking at mechanical ventilation, it is most preferable or ideal if one, it does not interfere with your building envelope. So what it's like when your building envelope should not be distracted or not be like, be a lot of, does not play a very be bulky elements that you see through your envelopes. But then again, it should be like, merge with it and be in a hidden place. Mechanical ventilations are usually not preferred to be in the exteriors. Two is when it is operated only when only needed. So these have to be in such a cases when these are not preferred when you go on have to be full on mechanical ventilated and increase the load on your building. Third is you provided the needed amount of air exchange. They have to play the role that they have been meant for. So they have to make sure that whatever the required amount of air exchange is needed, they try and follow up to that. Fourth one would be distribute your outdoor air when needed. So it has to make sure even the outdoor air that is there, it should be able to like keep up to that. And fifth one is not interfere with other systems. So make sure whatever this mechanical ventilation is, it should not deter or it should not affect the other systems. And sixth and final point will be quiet. Usually, the mechanical ventilations are usually too bulky and very soundproof. So they have to try and be in such a way that they should not be like too obvious that it's there. So why exactly do we need ventilation? So now looking at this, we saw two categories of natural and mechanical ventilation. We would majorly looking at natural ventilation because that is where our role in this climatology would be. So looking at your purpose of your ventilation, why exactly do we require ventilation? So one would be to provide, let's look at the few features. One, it provides sufficient supply of air of oxygen for the physiological needs of a human being. So basically it's talking about how it is, it's a basic requirement for us. We can't live without oxygen. So that is one. We have to have a proper sufficient supply. If there is a lack of, if there's a very less supply of oxygen, it ends up you having like a lot of health issues and all that. Two is your remove the products of respiration and bodily odor. So if there is not if it's not ventilated, the place is not ventilated, your products of your respiration, the heat that you let out and the bodily odor, keep circulating inside the building. All these things should have to be let out. The other one would be remove the contaminants or the harmful chemicals that have been generated from the building. So if it's not let down, do you see like how many contaminant spaces and all such? These guys have the issues. Yeah. So the other one thing would be to remove the heat generated by the people, the lighting, the equipment inside the occupied space. So you guys, humans, the lighting equipments and all of those elements let out heat. So how this goes about is what we are trying to do is, one, if there is a movement, air movement, the place cools down, thereby it actually reduces the heat that is being created into the building, right? Okay, so looking at it, the other purposes would be what your purpose of ventilation would be to create some degree of air movement, which is essential for feelings of freshness and comfort. So usually a velocity of 0.1 to 0.3 meter per second is required. So it's talking about how a degree of air movement is required. The feeling of the fresh air on your face and all of those such elements is what you're talking about. Next would be your convective cooling. The exchange of indoor air with the fresh outdoor air can provide cooling. Even if the latter is at a lower temperature than the indoor air, the moving air acts as a heat carrying medium. So it's talking about how we had earlier stated that due to temperature differences, how the movement of air is carried about, and how it talks about how cooling the entire space. And the last one would be your physiological cooling or your psychological cooling. That is the cooling the environment of living. So it's talking about how the feeling of movement and how the space created for you would be cooling for you. So you have that element like when you see trees moving outside, how you have the feeling of coolness and such. So similarly, you're talking about the physiological cooling. Now, what exactly talking about the purpose of natural ventilation? Let's go about looking at what are the major principles of natural ventilation. So how does this work? Yeah. So for the air to move in and out of the building, a pressure difference between the inside and the outside of the building is required. So that is the major key ingredient or key element that helps us to proceed with it. So the pressure difference, how does this pressure difference is exactly caused about? It's talking about one is your wind or your wind effect. Two is your difference in air density due to your temperature differences between your indoor and the outdoor air. So, which we would be like, we'll try and make you understand by using this two examples, that is your stack or chimney effect. And the last one would be a combination of both your wind and stack effects. So when we are looking at your wind-driven ventilation principles, there are different basic principles of the natural ventilation. It depends upon the number of openings in a space and the difference in your outer and exterior pressure. It's talking about how this temperature pressure differences and your wind acts upon to create your ventilation. So in this subcategory, you would see there is single-sided ventilation, a cross ventilation, and a stack ventilation. As you could see below in the given figures, how they have tried to clear out like what exactly these things means. So in the first image, you could see in the single-sided ventilation. The windows are usually situated only on the one side of the room, and the ventilation happens when the fresh air enters through the open windows. So what happens is the ventilation is only through one particular space. So this movement and all is not like, the movement of air is not clearly specified, and the movement is not very clear for the air to go about. In the second cross ventilation, what happens is that the ventilation happens primarily by the wind, which creates differences in wind pressures. So it's talking about how the wind from the outside enters in, it picks up the warm air that is inside and pushes it out to create space for itself. So thereby this movement and the continuous cycle happens. Whereas in the stack ventilation, it's actually the type of ventilation is primarily driven by the warm air rising to the top, creating a pressure difference which drives the ventilation. For example, in your operable skylights along with the windows and all different kinds of it. It's talking about how when the heated air, it's actually talk about how the pressure or the density of air is. So the warmer air moves up, right? So as it moves up, it creates a void zone, which the outside cool air tries to fill up, and thereby it pushes the air outside. So it's talking about, as you could see in these figures, how these are subcategories and how these goals go about. Yeah. So you could also, if you were talking about how these techniques are being used in the old times, about how these people are going about. So how these different openings and different, effects have been used. So talking about your courtyard effects, your stack effects, chimney effects, or your use of even your jalis are actually coming about in the from the past, how they've actually tried to make an influence in the present. Yeah. So first we could see in this element like double aperture. So basically double opening, double aperture. So your double openings that is used for ensuring that the ventilation in a in example we are talking about an example that's Shah Jahan houses. So it's talking about how these things go about. So it's talking about how the air enters from the lower level. Whereas the warm air moves up and goes out to the in the upper opening, as you could see here. The air enters in the lower, it pushes the warm air and pushes it out. So it's just basically in a single, even in a single wall and a single aperture, how the movement of air is classified. Yeah. In this thing, you could see how there are multi-directional wind catches. It catches the winds, and when the houses are very closely packed and the movement of air is like, in the upper levels. So these wind catches actually catch the air and they divert it into the lower part of the house, and then this wind thereby moves about throughout the house. You could also see the windows for the view. So windows or your apertures, which are actually used for your views, can also be end up being for your ventilation also. So as you could see, it's an example in your amber coat. Then talking about your column courtyards. So these, it's actually most common or the most preferable cooling system. There's actually, this is an example in a plan you could see in Divanic House or in your Red Fort, Delhi. So we already spoke about how the pressure differences go about, right? So in this pressure differences, we will subcategorize and look at a few examples about how these pressure differences play a major role in the ventilation of air. So looking at the stack effect, we could see that in the stack effect, these guys go about by creating one, it's a crawl space or a place where the humid or the heavier, denser air enters in. What happens is that your warm air actually moves out, so the warm air expands, whereas this particular zone is actually a void, which creates a void as it moves up. So thereby, this creates a pressure for these guys to enter into this. So about how this particular cycle of movement goes about is what your stack effect exactly is. So looking into the theoretical or detailed part, let's talk about it. So when the air movement is due to the temperature difference between the indoor and the outdoor, the flow of air is in the vertical direction and is along the path of the least resistance. So the temperature differences causes density differentials and therefore pressure differences that drive the air to move. So it's talking about how various different elements difference create to the movement of air. So one, you're talking about how your temperature difference goes about to create your density difference, and your density difference thereby creates your pressure difference and thereby causes the air to move. Yeah. So trying and understanding how exactly the stack effect occurs, let's try to look into detail. The stack effect relies on the thermal forces that is set up by density differences. So these are basically caused due to the temperature differences, and it's basically from your indoor and your outdoor air. The principle is the same as in the wind generation. So the indoor temperature is higher than the outdoor temperature. So what happens in this? The warmer air in the building rises up. The upward air movement produces a negative indoor pressure at the bottom. So thereby what happens is the positive indoor pressure is created at the top. So the warmer air flows out of the building near the top, and the air is replaced by colder air out on the outside air that enters the building towards the base. So it's basically like what we have spoken about in detail. The air moves up, thereby creating a positive pressure on the upper place, and it moves out. And the place that it moves out from, it creates a negative zone. And the outside air, the cool air, tries to get inside the building to have a normal pressure. It's trying to give a pressure. So this pressure difference is trying to nullify, and it tries to have a normal pressure. So this one. So how do you think you can make it work, and how you could implement is what we are trying to see. So the special provision can be made for it in the form of the ventilating shafts. So the higher the shaft, the larger the cross-sectional area and the greater the temperature difference. So therefore, the more air would be moved. Just talking about how you could create large shafts and how these things can go about to create, instead of having like individual zones, it could talk about how overall it could try and suit the purpose for it. Just talking about how the stack ventilation, you could work it out in systems, in sections, is that in maybe when you're having very tall rooms in this thing which are all commonly shared, or maybe when you have this tall rooms that act as shafts in the edge, yeah, or you could have this in the center with being its the tall rooms, it will be within it, or maybe the staircase would act as your stack element. So instead of having just the space for like a center shaft, it could also double as your staircase. So we had looked about like what exactly your stack effect is. Now looking about the other reversal of your stack effect would be your wind scoop. So what exactly is your wind scoop? So wind scoop is nothing but the large intake opening captures a very large air movement above the roofs in a densely built up areas. So it's talking about how large, they try to capture the air movement above the roofs in this usually packed up in your densely built up areas. So it's talking about the water seeping through the porous pottery jar. So it captures the air. It seeps through the porous pottery jar. So what happens is these have hold like water or something. As they move in, there's some this air that is being humidified, or this like cooled down, more drips onto the charcoal. Then thereby the air is filtered, and this moves on in a downward movement. That's actually what we had previously said. It's an opposite. It's basically your reverse stack effect. So basically, this is device is very useful for ventilation. So for a basic ventilation, this is good. But then again, it's not that the air movement is very not very strong when compared to your stack effect. It's just not so strong effect for your physiological cooling. Yeah. So air enters, so it's talking about how an example in the previous era it has been. So the air enters the wind towers. So the wind towers that we had used for the stack effect for the movement of air to go about. Whereas in your wind scoop, these actually double as for you to capture the air. So as the wind enters it, it hits the area, and it becomes, it becomes cooled down through the walls that are being there. And it, due to the getting cooled down, it moves things down because of your air movement. So what happens is during the day, you could see the air hits the space, it gets down, and because it cools down in the overall area, because it's under the ground, it gets cooled down. And then you have your fountain that also cools it up. But then again, in the place where the people are existing, and due to because it's getting heated up, the air moves on out and goes out through the wind. So what happens is that it's talking about how your tower walls absorb the heat during the daytime, and they actually end up releasing at the night. So during the day, the air that it captures is turned into cool air because of this your wall tower walls, wind tower walls. Whereas these it releases the warm air during the night, and the air that it enters becomes warmer, and thereby heating the house at night. So you could see like how we looked at a few sections of your stack effect, looking at your wind tower sections. So it's talking about how you're giving the water supply, how this movement of air is controlled, and how your air is getting cooled down. Yeah. And you also have like multi-directional wind catches. It's not only about the one way, but you have like different ways in which the wind could be captured. Yeah. So then again, looking at your what exactly is your courtyard effect. So we're talking about your stack effect, and then you have your wind towers, and then looking at your courtyard effect. So basically, due to the instant solar radiation in a courtyard, the air gets warmer and rises in, whereas the cool air from the ground level flows through the lower openings. So you could see like how in this given example, how they have actually tried to show how the air due to the radiation moves up, whereas the courtyard and the water bodies, it tries to cool down the system and tries to move it up. So looking at a few examples of your courtyard effect, you could see that how different subcategories and how different ways they have tried to go about. So you could see in the given figures how different courtyards with different sizes and how in a different position they affect the flow of the air. Yeah. So it's talking about how when it's centralized or if it's a very small area, and when it's a very linear way, how the airflow goes about, and how if it's going to be split up, how the airflow and how the distribution of the air would be. You will see a few examples about how the courtyards have tried to have their impact on the various buildings. One of the example is the American Institute of Indian Studies, which is in Gurgaon. If you could see like how this in central courtyard, there has been a sunken courtyard that's inside the building with the water body in the landscape, becomes not only about this cooling for your physiological cooling, but also for your psychological cooling. So how exactly this courtyard effect works is basically in places where the night ventilation is not very effective for cooling and the night sky radiation is only the answer. So how these goes about is that your parapet walls, these are actually trying to towards the roadside are trying to be very higher. So these try and avoid your outside heat that is from entering into the building, whereas it tries to create or circulate the air that is being inside the building towards in all your living spaces. So it's talking about how to facilitate the movement of cool air into the house, the parapets are not built inside towards the living area. It's only towards the exterior that they are built to prevent the outside air from coming in. Whereas in the inner side, those parapets are avoided, so the movement of air is uninterrupted. So this is one example in the section of the Shahjahanabad in Delhi. So we were talking about what the ventilation is, how different types of effects are, but how does it goes about this? All have one basic principle that is talking about your pressure differences. But this pressure differences which you go about, we have to try and look into detail about what are the terms that go about in this pressure differences and how this voids and elements that goes about how this actually play a major role in your ventilation. Yeah. So talking about your wind shadow. So what exactly is a wind shadow? So when the moving air actually strikes an obstacle such as a building, this will slow down the air flow, but the airflow will exert a pressure on the obstructing surface. This slowing down process affects a roughly shaped wedge-shaped mass of air on the windward of the building, which diverts the rest of the flow air upwards and sideways. So it's talking about how when the movement of air, it gets obstructed by the building, it tries and gets deflected and tries to create its flow to be in the same way as it was earlier. So when this flow is happening, this actually the side that's getting obstructed is actually a windward side, and the side behind it would be your leeward side. So it's talking about your windward direction and the leeward direction. It's talking about how the airflow happens and how this ends up creating a negative zone into your building. So what exactly is a wind shadow is? It's a separation layer that is formed between the stagnant air and the building on the one hand, and the laminar airflow on the other hand. So this laminar airflow tends to maintain a straight path after it has been directed. The stagnant mass of air that is being formed on the leeward side but is at the reduced pressure, the movement is light and variable and is often referred to as wind shadow. So as I had informed earlier, it's talking about how the air, once it goes and it starts following the same flow of air, there is a stagnant mass of air that it leaves behind. Yeah. So where there's no flow of air, there's a negative pressure zone, which is referred to as your wind shadow. So it's talking about wind shadow. Let's try and understand how this air, we were talking about this two subcategories, air movement and natural ventilation, right? So we looked at ventilation and what natural ventilation goes about. But try and understanding like how this air movement happens, and the air movement will be looking at two subcategories. One would be your air movement around the building, and the other would be your through your building. So looking at your air movement around the building, can you see how this goes about? So it's talking about your wind effect. So this is nothing but when the airflow is due to the wind, the airflow happens through the openings in the windward walls and leaves the openings in the leeward wall. So it's talking about how the wind where it hits with the highest pressure, if you were to have openings, the wind tries to enter or flow through your building to form or continue the way or the flow that it's previously going in. Yeah. So it's talking about how this wind effect happens. So your wind flow. These wind pressures are generally high or positive on the windward side of the building and low or negative on the leeward side of the building. This is how I previously stated that your wind pressure is highest on the positive on the windward side and the negative on your leeward side, thereby forming your wind shadow. Yeah. So the occurrence and the change of wind pressures on the building surfaces, what does it depend on? So one would be your wind speed and your wind direction relative to the building, the location and the surrounding environment of the building, and the shape of the building. So let's see how these subcategories go about. So this wind induced pressure differences. So the positive pressure is actually created on the building sites that face the wind. Going about how, let's keep in mind of these terms if we're talking about the windward and leeward. So the side that is on the side of the wind is your windward side, and that's that is like on the opposite side of your wind direction is your leeward side. So it's talking about the results in a negative pressure inside the building, which is sufficient to introduce large flow through the building. So what happens is that, can you see this image? It's talking about how there is a positive and there's a negative zone. So it is, your building ends up being in a very negative zone, and what it tries to do is that when you create openings, the air tries to flow through them, fill them, and it tries to reach the negative pressure zone that is behind your building, thereby creating the flow of air that's around. So in a general case, the airflow of air is induced on the windward side and the outflow is on your leeward side. So that's why the understanding of the flow of your wind direction is a very important and a key feature when you're trying to provide your windows and openings. Yeah. So the air flow through the external openings is mainly attributed to a wind-induced pressure difference across it. So looking at this again image, so you're talking about how an increased velocity is found at the ground level at the sides of a tall block. This is usually a useful purpose in hot climates, although if the tall block is not fully closed but is permeable to the wind, those effects may be reduced. It's talking about how the sizing of your different building blocks next to you or around you actually makes a major impact on the wind flow or the wind pressure differences. So if a low building is located on the wind shadow of a tall block, the increase in height in obstructive will create the increase in airflow through the low building in a direction. So what happens is that the lower return wing of the larger vortex would pass through the building. So about how if the building is very high, there is a very large negative zone that is being found on your wind shadow direction. Yeah. So it's talking about how this ends up creating a negative pressure. So the air that is moves about, if you were to create an opening, it rushes back inside to create your positive area. Now again, looking at how about we were looking at different blocks. Now looking at your planning wise. So if in a rural setting, so a single story building is placed in rows, that is usually the most probably preferred pattern, Zephyr and pattern. The stagnant air zones are levered from the, what happens if they were to be closely packed, they would have the your wind shadow would overlap with the second row. Yeah. So to avoid this, what could be done? So it's basically the spacing of 6 times the building height is necessary to ensure the adequate air movement from the second row. So that is basically just 5 times the height space rule is not quite satisfactory. It has to be 6 times. Even 5 times is not enough to avoid the wind shadow limit. So how do you actually cut down from this setting and how do you actually go about this? So if we were to have a similar setting, but if the buildings were actually staggered in a checkerboard pattern, then there will be more uniform and your stagnant zones are almost like eliminated. So the air moves on about to create very minimal wind shadows. So that is your air shadows. Whereas like another example where we could see is that what other element could impact is your, we were talking about your buildings, but also your trees or your landscape also affects your wind flow. You could see how you could either divert or channel the wind to flow towards your building, or even cut down on the filter it in case the places that you don't want it to be. Looking at this, you could see the landscape to channel the cooling breezes from coming from one direction. But if they were like something like the storms or very harsh winds that are coming, it tries to break down so that by the time it reaches the building, it's very cool and supple. Yeah. Okay. So that is around the building. So around the building, we were talking about the wind shadows, about how tall buildings, small buildings affect, how the planning affects, how the landscape affects. But in cases of when it is through the building, the elements we have to consider are many. So if you're talking about this thing, there are the major factors that are influencing the air movement through the buildings will be one, orientation, then cross ventilation, the size of openings, the position of the openings, and the control of openings. So we'll be like slowly getting. So looking at these elements like one by one. First, let's starting about with your orientation and elements. So let's this category about ventilation and cooling. So what it stated is that the both the design and the orientation of the window influences a building's interior air, interior flow and the cooling. So if you look at the examples with the figures that have been given, in the first two scenarios where the two window layouts actually they have the strong air movement because they have an uninterrupted airflow. But what happens is it's uninterrupted, the flow of air is fast, but then again it affects only a small part of the room. Only a small part of the room ends up getting the cooling. Whereas if it were to have diverted such that the air movement is minimal, but then again what it does is that though the lower velocity, but the air moves through a larger scale of the room. So what I say, as it moves about, it cools down the space that is there. So though the velocity is lower, the area that it covers is more. So looking at this, a few more examples where you have a change in the window design also has an effect on the interior air circulation. Can you see how the sashes, the size of the sashes that are given about your course about to create, how the flow of air would be in entering into the building. Yeah? So a few coming into few like the scientific calculations and stuff, like few examples how it goes about is that. So what happens is that you have to understand how this prevailing wind directions actually have influenced it and how these can be considered. So it's talking about how the size of the openings are not only the only elements that goes about, but also the direction in which the wind enters the building. This actually been found that a wind that is being incident at 45 degrees Celsius, 45 degrees would increase the average indoor air velocity and would provide a better distribution of your indoor air movement. So looking at your first subcategory where the air movement is straight and your size of your openings varies. So even with having your entire space that's been opened up, your average the cooling area of this thing would be just 47%, whereas when it actually hits at an angle of 45 degree, the space that is being covered is more comparatively very larger. You see that it's 65%. Yeah. So it's talking about how your angle that you have been oriented, it actually plays a very important role. So it actually often happens that an optimal solar orientation and optimal orientation of the wind do not coincide. So these two are very tough to try and figure out. But then again, in equatorial regions, a north-south orientation we prefer for a sun exclusion. But most often the wind is predominantly easterly. So what happens is that it's one such example where though the orientation you have fixed for to remove your sun's heat from entering into the building, but you need to try and consider the wind, that direct wind movement also, so that you could have proper ventilation. So this, like few facts like these go about to understand. So this usefulness of the above findings is very actually obvious for such situations. It actually resolves very contradictory requirements. So you could see like how this thing goes about. Yeah. So in cross ventilation, so what exactly is cross ventilation? So in cross ventilation, it actually utilizes a very differential air wind pressure. So we already saw how about in cross ventilation, the movement of air varies when it's compared to the different subcategories due to the openings, right? The area that it covers is larger or smaller, it depends upon, and also thereby it also affects your wind movement or wind velocity. So when the air outside is cooler, the windows on the opposite side of the home can be open. So what happens is that the movement of air could be uninterrupted and the flow could be continue on. The cool air enters on the windward side and passes on the other side, so thereby replacing the warm air that is inside with the cool outside air. It's talking about how different your positioning, your building could be, your openings could be positioned so that the movement of air is uninterrupted and the air from the windward side can move on to leeward side, whereas cooling your building on the. So I'm just trying to understand a few scenarios where your cross ventilation goes about this. You could see a few examples when there is a single opening and when there is an opening on the same wall, if there were some opening in the wings, or when it's an adjacent wall, or when it is an opposite wall. So we're trying to understand a few scenarios how the movement of air would go about. So basically with the windward opening and no outlet, so if that is in the first case scenario, there's a very a pressure is built and the air is the very worst. So it doesn't know how to go about, and the movement of air is very disturbed and thereby increasing discomfort. So in some cases, what happens is that when the movement of air that is entering and they're trying to move out is very quick, it has like a very large oscillating the pressure change. So this is also known as the buffeting, which can also be made to produce by an opening on the leeward side with no inlet. So this happens when you provide the openings on the leeward side and when there's no outlet. Yeah. When your inlet and air on the size of your opening, so other condition. So in the both cross and stack ventilation, the amount of heat that is removed from a building is directly proportional to the inlet and the outlet areas. The larger the inlet and outlet areas, the more air can be travel through the building, and or more heat can be removed. So it's a basic concept where the more you have the open, the more elements can enter in and go out. So basically increasing the inlet and outlet areas increases your ventilation. Then your positioning, how the way you're positioning your opening so that the movement of air could be. So to be effective, the air movement must be directed at the body surface. So it's talking about how, if the air or opening is above your head and the air movement just goes on the upper direction without, moving to, without touching the body, there's no use, right? So about how you go about is that in this building terms, this means that the air movement must be ensured through the space that is mostly used by the occupants. It has to make sure that the air that goes about is being used by the occupants. So the living zone, they have thereby subcategorized what's the height at which or through which the air has to be moved. So basically up to 2 meters of height. So in the larger solid surfaces, what happens is that when you in the plan, if you're looking at about how the movement of air goes about, so the air, if there were some elements that try and deflect your air, so when the air gets deflected and moves about, how the air gets pushed about by surfaces and then creates a zone. So you could see how it gets deflected. So in this case, can you see how in a plan it gets deflected by the wall, whereas here it rises and gets deflected by the facade. Facade gets deflected to the lower elements and then moves up, or it could also be deflected to the upper direction and moved out. So this in an example in a two-story building, it's trying to show you how the airflow in a ground floor is very different when compared to your first floor. So it's what you could do is that you could try and deflect it by you having another element or your parapet wall added here. So the flow of air is very similar. So we want it to be in this lower level, which is very feasible in the ground floor. But in the upper floor, it's not such action. Maybe the parapet walls not only end up being for safety, but also can be double as air deflectors to go into the occupant zone. So few examples about how different your sharing devices come into that, how your sharing devices come and help you in the flow of openings, how the control is going towards it. Another subcategory about how this movement of air is going to be when you have an horizontal louver or when there's just a small slot between openings, when one with your roof overhang, other one with your partition up to your level floor. So it's not only about the exteriors, but also your interior, how this, the elements or your walls can, deflect and create pressures at airflow. Looking at different openings, types of openings and how the control would be. So sashes. So sashes are basically horizontal elements, or this could be like how they could go about. So sashes, they divert the airflow towards upward. So only when the casement or when it has a reversible pivot sash will it channel downwards into the living zone. So it's talking about how these sashes are subcategorized. Usually these are similar to the first figure, but sometimes when they are being when their position is diverted, they could also deflect the air on the lower level. Then you have your canopies. These canopies can eliminate the effect of the pressure buildup above the window. Thus, the pressure below the building will direct the air upwards. So the gap left between the building face and the canopy would ensure a downward pressure. Thus, a flow directed into the living zone. Yeah. Louvers. So louvers and shading devices may also be present a problem. So what you have to go about is that these have to be considered to be such that so the position, the way they are being positioned for the air movement to enter the building also plays a major role. So if they are slightly in upward direction, what will happen is that the flow of the air direction will move upward, thereby not being in the occupant zone and would move on above. So it's talking about how your position of your louvers also play a major role. So looking at openings, we also talk about some categories about how when you have your openings, you also have to consider the elements that are there in your openings. So one would be a mosquito screens and nets. So these actually substantially reduce the airflow. So if you look at it, a cotton net can have a reduction of 70% in air velocity, whereas a smooth nylon net is just have a factor of just 35%. So this reduction is greater with the higher wind velocities and it's also increased with the angle of incidence. It's talking about this is not the standard amount, but then again, if the airflow is more and if the angle of incidence is more, the air that is being reduced will also be more. So looking at these subcategories in plan, it's talking about how the movement of air is deflected in different ways if they were interior walls or partition walls it goes about. You could see if the air in the G or the third image, how the wall is very directed towards the wind flow, how the wind shadow would be affected, and how in other subcategories how the wind shadow would be. Yeah. So talking about your inner obstruction, the air must be free to move from the inlet to the outlet. The two are not very useful if there is a wall between them. Is it true or not? Yeah. So the flow is only if the flow is undeterred and undisturbed, the movement of air would be clear. So in addition, the cross-sectional area of the parts from the inlet and outlet should be at least the area of the smaller of the inlet and outlet. So a clear path between the inlet and outlet must be maintained with aspect of furnitures too. So not only about your inner partition walls, but also with respect to your furnitures, it has to consider. So we try to look about the air movement in different subcategories. Let's try and look at one rough example about how in a planning wise they have tried to create this natural cooling systems. So one example is in JAISALMER. So how they have tried to solve this issue is with having dense clustering of buildings. So what happens is that being tightly packed, they have no place for the hotted air to come in, or it's like self-blocking it off. So the sun control through orientation and structural projections, massive constructions for roofs and walls, courtyards and other air ducts for ventilation. So these are the few elements that they have added. In addition to that, the types of houses have 2 to 3 story structures and can be considered as typical houses or as JAISALMER. This is like a common typical plan. So these have also additional rooms and a balcony projected on the street. So how this goes about is that not only in their aspect of the building, but also in the planning aspect. Can you see these are the major streets? What they do is that these are majorly oriented from the east and west, and the minor are on the right to this. So this compact structure of the housing doesn't allow the sun's rays to penetrate and also serves as a device of shading. So it's talking about how we are trying to understand that how understanding of your air movement and your natural ventilation plays a very major role, and how using it to understand about how the air movement goes about because of this pressure differences and your requirement for your ventilation is what we have seen in this chapter. In addition to your example that we have seen here. So it's talking about these elements are very important to implement. Understanding these elements, how people have used it in the past, is very important for you to design in the future aspect about how these can be implemented in your design. So this is all for you this chapter. So we'll wrap up with this session. So thank you.